Hi everyone, let's take a look at the following example. Find the antiderivative or the integration of 4 times x squared divided by the square root of 5 minus x to the power of 3 with respect to x. Step number 1, you have to use a method called the method of substitution. And again, the key concept behind this method is to let u equal to the difficult part such that the derivative is going to be a scalar multiple of the other part. So if you let u equal to 5 minus x to the power of 3, this means du by dx, which means you're finding the derivative of u with respect to x, this equals to negative 3x squared. Now, what does that really mean? You have to go back and isolate for x squared dx. So again, on the right-hand side, I'm going to write down x squared dx, which basically means I have to divide both sides by negative 3. Let's move this a little bit for you. And on the left-hand side, this is going to be du divided by negative 3. Now, let's switch colors here and let's put a box around that. So the concept here is x squared dx is right here, which we're going to plug in a moment. And likewise, if you look at the other part, u, which is basically 5 minus x to the power of 3, is going to be right there. So if I go back to the original color, I can let the entire given equal to, again, couple of steps I'm going to show you at the same time. This number 4 could be brought to the front. So again, the constant is actually independent of the antiderivative. So it's going to be 4 times the integration of, instead of thinking x squared, dx is going to be du divided by negative 3. And instead of thinking 1 divided by the square root of 5 minus x cubed, you're going to replace it with u. Just like that. Now, look what happens. I can bring all the numbers to the front. So instead of having negative 1 over 3, I can bring it to the front, combine it so that it's 4 divided by negative 3 times the integration of 1 divided by the square root of u, which is basically in exponent form, u to the power of negative half. And again, you're finding the integration with respect to u. Now, when you find the antiderivative of u to the power of negative half, you have to add the exponent by 1, divide by the new exponent. So again, negative half plus 1 is going to be half. And if you're dividing by half, that's the same thing as multiplying by 2. But I'll divide by half for you, just like that. Don't forget you're adding a constant c. You're not looking for one answer. We're looking for infinite many cases, also known as a family of solutions. Now here comes the final answer, and you can always double check by going the opposite direction. If I simplify this, again, you're dividing it by half, so really multiplying it by 2. 2 times 4 is going to be 8, divided by negative 3. If you go back and you think about u is the same as 5 minus x to the power of 3, which I'm putting underneath the square root because the square root is the same representation as to the power of half. Now, how do we know if we're doing it right? Again, I would say spend 1 extra minute to double check by taking the derivative of the answer. Now, I'll do this with you right now. I would like you to write it down though to make sure you're with me. So again, if I take the derivative of 5 minus x to the power of 3 to the power of half, the half is brought to the front, which I'm applying the chain rule. Half times 8 over negative 3 will be 4 over negative 3 times 5 minus x cubed to the power of negative half times the internal derivative, which is negative 3x squared. And when you clean this up, and of course, when you differentiate a constant, that's going to be 0. And when you clean this up, you get exactly the question back. I hope this makes sense.